Assalamu alaikum, my dear students. I hope all of you are fine and doing well. So, in our today's lesson, we will discuss about the experimental verification of the Boyle's law. As earlier, we have already learned about the Boyle's law. Basically, Boyle's law is simple the relationship between volume and pressure. And Boyle's law, the Boyle's has just simple given the relationship between volume, where volume is inversely proportional to the pressure. So in turn, when there is an inverse relation, so by changing the one variable, the other will be also changes. When the volume is going to be increased, it's mean the pressure decreases, and when the pressure increases, the volume will be increases. So there is a inverse relation between volume and pressure. From this picture, we have just filled this beaker with a gas, and here its volume is larger and the pressure over it is just 5 kg. On the other hand, when we increase the pressure 5 into 5, total increase of pressure is 10 kg, then the volume of the gas decreases. So this is the simple volume of the gas that has been decreases by the increase of the pressure. So this is a simple experiment that we can also have a look. On the other hand, the other simple experiment that we can do at home, it is you fill a balloon with the air and the you just squeeze it. You may be able to see that the volume of the balloon decreases. It's mean when we increase the pressure by squeezing the balloon, its volume decreases. So this is a simple example from our daily life. Next we have the experiment that has been done by the Boyles to check the effect of pressure on the volume of the gas. In the first step, he just keep the temperature constant. There was no change in the temperature. And here the temperature is at 300 Kelvin and the volume of the gas that is filled in the movable piston. So here the pressure is almost at zero point 0.1 and the volume of the gas is 4. So when the volume of the gas is equal to 4, we can say that dm cube or centimeter cube and the pressure is almost 1 atm and the temperature is constant. After some time, you just increases the pressure by moving the piston down. Now here the volume of the gas is equal to 2 dm and the pressure is equal to 2 atm. So the volume decreases from 4 to 2 and the pressure increases from 1 to 2 by keeping the temperature as a constant value. So this was a simple experiment done by the Boyle's law. So he just proved that when we have a product of P1 V1 is equal to P2 into V2. The P1 V was having 1 and the volume we have 4. It is equal to P2 which is 2 atm multiplied by volume V2 which is 2 atm. So we have 4 is equal to 4. It's mean the product of P into V it is a constant values. This was a simple experiment that was done by the Wiles. Next, we have the example for this experimental verification that how we can be able to know the unknown volume of the gas. Here we have a gas whose volume is 10 centimeter or 10 dm cube and it is filled up in a closed vessel and the temperature here we have 0 degrees Celsius and the pressure is 2 atm or 2 atmospheric pressure. Then the gas is allowed to expand at the pressure of 2 atm. What will be the volume of the gas if the temperature is kept 273 Kelvin? 273 Kelvin means 0 degrees Celsius because when we convert the 0 degrees Celsius, to Kelvin scale by adding 273 is equal to 273 Kelvin. So here one thing is constant, which is temperature. Now we have to calculate the volume. The V1 or the initial volume of the gas we have it is 10 dm cube, that is given. Then we have the initial pressure, which is the P1. It is equal to 2.5 atm. Then we have to find the volume V2, which is the final volume of the gas. And the pressure air has been reduced, which is the P2 equal to 2 atm. And the temperature is constant. Now we have to find that variable by the simple use of the formula which was given by the Boyle's law in its relationship P1 V1 is equal to P2 into V2. Here the P1 is the initial pressure, which is 2.5 atm, and the multiply by V1, which is 10 dm cube, is equal to P2 pressure, it is 2 atm, and multiply by the volume V2 that we have to find. So by rearranging this equation, we will get 2.5 multiplied by 10 divided by 2. And the answer we just gained, it is 12.5 dm cube. So the volume V2 is 12.5 dm cube. At the start, we have just seen that the volume is 10 dm cube and the pressure is high. But when we reduce the pressure, now the volume increases from 10 to 12.5. So this is a simple effect of pressure on the volume of a gas that we can be able to find by the use of the Boyle's law relationship. So this is all about today's lecture. I hope you guys understand, and if you have any queries you may ask me about that in the comment section. And the next topic we will discuss about the graphical representation of the Boyle's law, that how we can show the Boyle's law relationship with the help of a graph. So that time you guys have a good day and Allah Hafiz.